Oh, hi everybody! Welcome back to our videos! Woo! Ow! Byron, Shauna, come on! Fine. Ow! Oof. Are you people ready for some more math? Because I know I am. I said, are you ready for math? We know. Yes, we're ready. Now, let's just get this thing over with. Great! So today, we are learning more about experimental probability. And we decided to skip the other pages because we're going to do something very fun. We're going to do loads of experiments. Are you ready to bring in the fun? Then fun it is. Let's begin with our first segment, the wheel segment. What I like to call the fun segment. This is a 3-part wheel because it's split into 3 parts.
Oh yeah, it is. Hi, I'm Squeak. Ooh, what are you gonna do with it?
Well, we don't have an arrow, so I don't think we could be able to spin it.
Oh.
But one of you guys could pretend to be an arrow and spin yourselves to see which number you land on.
Oh, that sounds like fun. I would want to give that a try.
Okay.
Me too.
Me free.
Oh.
Sure. Well, I know you guys will do it together.
Aw.
But how are we going to do this? Well, tabulating the results of an experiment is not simply by just staring at it. We have to physically do something with it. So, let's put our friend, or the pretend arrow, on the spinner, because we don't actually have an arrow. We can pretend that Wally is an arrow, and we can spin him around.
Woo! This is fun.
And Wally stopped at 1. This means that if you were to spin the wheel that way, you would end up with a 1, 2, or a 3. Whichever way you go.
All right. Now we are ready to start the fun. How many turns should we spin around?
How about 18? 18?
Wow. We're going to spin the wheel 18 times. Oh, this will be good. All right. First time. Yeah.
First time is 2. That means we have to jot down 2. Come on, everybody. 2. Remember, we're going up to 18.
My turn now.
Okay. 3.
Ooh. Cuckoo. Cuckoo.
2, 3, 1. Wow. We're tabulating the results of this experiment really quickly.
Oh, 1 again.
Wow. Looks like we have a lot of numbers here. But this is going to take too slowly. I know what else we can do. We can make 2 people spin around at once.
Woohoo!
3 and 1. So that means a 3 and a 1. Because one of them landed on 3 and the other landed on 1. Very good, everybody. Let's keep rolling.
Yay, a 2!
Theoretically, if we continue this experiment on and on forever, until the 18th one is done, we should get somewhere to around, hold on, sorry, this many 2s. 1, 2, 3, 4, 5, 6 2s spun at once, and we should get somewhere to 6 3s. 1, 2, 3, 4, 5, 6. And finally, 6 ones. 1, 2, 3, 4, 5, 6. And 3 lots of 6 is 18. So that's the end of the experiment. What do you notice about all of these numbers here? We've done the experiment. And we can theoretically know because this wheel is divided into 3 equal parts. What do you notice about each number?
Oh, there are 1, 2, 3, 4, 5, 6 twos, and 1, 2, 3, 4, 5, 6 threes, and 6 ones. So there are 6 twos, 6 threes, and 6 ones. That means that both 1 and 2 plus 3, 1, 2, and 3 are all rolled equally, right?
That's right, Juliet. They're all rolled equally because the wheel is split into 3 equal pieces. When the pieces are all equal, there is an equal chance of them getting an equal amount, like 6 twos, 6 threes, and 6 ones. 6 of each makes 18 numbers in total. Let's count to see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yep, 18 different kinds of numbers. So that is the total sample space for the possibilities of rolling a spinner with 3 equal parts 18 times.
Wow, that's cool!
Yes, but that's only for 18 times. Huh? We can expand the pattern. We can do it 26 times, 92 times. Heck, we could even do it 237 times.
Huh?
But we would have to spin a lot. That would make us dizzy. Don't worry. There is another easier way to tabulate the results of the experiment without actually doing it.
Huh? What's the secret?
The secret is you have to figure out how many parts of the wheel that it has. This wheel has 3 parts. If we spin it 18 times, then we know that it's going to be in a 1, 2, or 3, right? It's going to land on a 1, 2, or 3. Well, since there are 3 equal parts, and we are spinning it 18 times, 18 is divisible by 3. So each number should be spun 6 times. You should land on 1 6 times, 2 6 times, and 3 6 times, which all together add up to 18. So the secret is to divide the number of spins by the number of parts of the wheel. For example, 18 is the number of spins, and 3 is the number of parts of the wheel. 18 divided by 3 is 6. But if the parts are unequal, it will be a whole other story. Look at this one. The outcomes for spinning a color on the spinner are not equally likely because the parts are not all the same size. You can do an experiment to find the experimental probability of spinning each color. So, although this is technically one whole circle, although this is equivalent to 1/2, this shape overall is smaller than the big yellow shape. So, the red triangular-like circular shape is a lot smaller than the yellow semicircular shape. So that's why it's not equally likely to spin all of those pieces equally, because they're of different sizes. However, it is equally likely for this one, because they are all the same size. Look. See? That's roughly as large as the other ones. But this, no way. This is a whole lot smaller than this big chunk of the circle. Oh, jeez. So, we need to find out something else. But what? Well, we can easily tabulate the results of this experiment without doing it as well. Again, let's find out how many spins. Record the results of at least 24 spins. So, we can spin the wheel 24 times. But if we spin the wheel 24 times, what would be 4/8 plus 1/2 of that wheel? Well, if we take a look, what is 1/8 of 24? 3? That's right, Sibby. 1/8 of 24 is 3. So red is spinned 6 times because there's a red and another red. But only one of the reds on their own would be spun 3 times. So red overall is spun 6 times because there are 2 reds, and 2 3s make 6. This is the same thing for the blues, because the blues are the same sizes as the reds. But the blues and the reds are not the same size as the yellow. So, yep, that's why they are all 3, because they're all the same size. But the yellow one is much bigger. So that means we all must know it must be bigger than 3, but less than 24. Chicky, can you estimate how much?
Ducky? Ooh. Now. 12?
That's right, Chicky. Yellow will be spun 12 times. Very good. Because as you can see, yellow is 1/2 of the circle. And what's half of 24? 12, of course. So 3 plus 3 plus 3 plus 3 plus 12 must equal 24. Because 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, and 12 plus 12 is 24. Now that is magic. See, you don't always have to do the experiment to tabulate the results of the experiment. All you need to do is divide the number of spins by the number of parts of the wheel, or if they are of different sizes, then just find one certain fraction of that number. So for example, this is 1/8 of the circle, and we are spinning it 24 times. So since 1/8 of 24 is 3, and there's another 3 here, we can say that red is being spun 6 times, because 3 plus 3 is 6. Same for blues, because they're both the same size. However, yellow is only half. So, half of 24 is 12. That's how we got that answer. So, we can secretly tabulate the results of the experiment with no arrows at all. Yes. In fact, it's pretty much the easiest method to use, instead of just spinning the arrow over and over and over again and expecting the same results. So, red is being spun 6 times, blue is being spun 6 times, because remember, 3 plus 3, 6, 3 plus 3, 6. And yellow's being spun 12 times. This is because 6 for reds plus 6 for blues equals 1/2 of that circle, which is 12 for yellows. All of these are the same size as yellow, but 2 of them are not. That's because 2 of them only make up 1/4 of the circle, and 1 of them makes up 1/8 of the circle. That's why it's not the same size as the yellow. But all 4 of these colors are the same, because they make up 1/2. But all the pieces overall are not the equally same-sized pieces, because this is a whole lot larger than this. Or these combined. Or even 3 of these combined, because 1/2 is larger than 1/3. So, that is it. I know we have been doing this super quickly, but, again, skip the other pages, because I think they were too difficult. Sorry, guys. But don't worry, at least we had a bit of fun. We learned that we can tabulate the results of the experiment without doing the experiment at all.
Wow! It's just like magic!
Yes, Fudgy, exactly. Mathematical magic. Do you want to do another one?
Do I ever? Yes!
So, let me give you a hard one. Imagine you're spinning this wheel 900 times.
900 times?
Yes. So, how many times will you spin 1, 2, and 3?
Well, the wheel is divided into 3 equal parts. So that means 1, 2, and 3 must be spun an equal amount of times. Well, 900 is divisible by 3, and 900 divided by 3 is 300. So, if you spin that wheel 900 times, you should land on one 300 times, you should land on two 300 times, and you should land on three 300 times. Because 3 of those 300s make 900, right?
Yes! You cracked the code. Well done, Fudgy. Wow. See? This is easy magic if you want to race ahead. But you know, it's not always advised to go fast.
Yeah, you always have to stick
With us, even if a lesson looks very easy and you could just zoom by through it.
Yeah, and plus, in The Tortoise and the hare gets very tired after running very fast.
Yeah, he might want to rest. The turtle's not tired at all. He's taking his sweet time. So, be more like the turtle. I think we went a little too fast. We've been 16 minutes through the video, and we've just ended it. Don't worry, it was not as fast. At least it's not 5 minutes long or something. That would be terribly fast. Okay, everybody. That's it from us today. I hope you enjoyed this probability video. And we'll see you all in the next video. Cuckoo, cuckoo! Wow, Cuckoo, you're very good at
Flying.
Whoa!
Bye! Bye-bye!